All right, today we're going to talk about graphing equations of lines, section 2.3, and the essential question, what are the various forms that linear equations in two variables can be graphed? So one topic we're going to talk about first is what's called a parent function, and that's a most basic function in a family of functions. So for example, before in algebra we learned that we have linear equations, we have exponential and quadratic, and when you're talking about a parent function, you're saying, what is the most basic form of a linear equation or quadratic or exponential that we can have? So for today, we are just talking about linear. And the parent function for a linear equation, the most basic function that you can have, is the equation y equals x. That's going to be a line with a slope of 1, because if there's nothing in front of x, that's like 1, and a y-intercept of 0. And it should just be a line that continues up 1 over 1, up 1 over 1. When we're talking about linear equations, we have a few different forms we can look at. The one we're probably most familiar with, the slope-intercept form, y equals mx plus b. M represents the slope, b represents the y-intercept, and you always start your graph at the point 0, b. When you're talking about the standard form of a linear equation, that's where you have both x and y on the same side and some constant number by itself. You have to have both a and b not equal to 0. So the standard form is ax plus by equals c. And then when you're graphing equations in standard form, you want to use the intercept method so that you can solve for your x-intercept, your y-intercept, and then you can finish the graph based on those 2 points. So for our first example, we're going to use a scale of 1 for all of these, and we're going to graph the equation y equals 2/3 x minus 4. So the minus 4 is our y-intercept. We always start at the point 0, comma b, which for us is -4. We have a positive slope, so that means as our line moves to the right, it should be increasing. So we're going to go up 2 spaces, because remember the slope is the rise over the run. We're going to go up 2 spaces and then to the right 3 spaces. Plot a point, up 2 and to the right 3, plot a point, and you can go for a few more points if you'd like. The other option is that you can do the exact opposite, where instead of going up 2, you can go down 2 spaces, but then you also have to go to the left 3 instead of the right 3, like what we did before. You can connect your points, and you have your first line. A second option, or a second equation, I should say, we have y equals -5/2 x plus 8. So again, 8 is our y-intercept. We start on the y-axis at this number. And then this time our slope is negative, so that means we are going to, instead of go up 5 and to the right 2, we are going to go down 5 and to the right 2. And connect your points. And if I had more space, I also would have the option of going up 5 and to the left 2 spaces. So you just do the opposite of exactly what you just did. For the third example, we have y equals 3x minus 7. So it looks like there's nothing given to us for how far we should go over, But remember, we can multiply or divide any number that we want by 1. So this is really like 3 over 1 for our slope. So we still start at our y-intercept, which is -7. And we're going to go up 3 spaces into the right one. You can also, from the y-intercept, go down 3 spaces into the left one and connect your points. This last example is a little bit confusing because it says y equals 5 minus 2x. This is like we switched in y equals mx plus b. We just rotated where the b and the mx are. So whatever the coefficient of x is still going to be your slope. This time the y-intercept just came first instead of after the slope. So you still want to start at the number 5. And again, it doesn't really look like we have anything for how far over we should go. But if you ever have an integer, it's always that integer over 1. So we're going to go down 2 spaces into the right one. And from our y-intercept, we could also go up 2 spaces into the left one. So here we have the equation 2x plus 3y equals 12. So notice how this time we have x and y on the same side. That tells us that this equation is written in standard form, and we want to use the intercept method to graph these two, or this equation. So for the intercept method, you want to solve for the x-intercept, and you want to solve for the y-intercept. And for the x-intercept, you're going to set y equal to 0 and solve for x. And then for the y-intercept, you will set x equal to 0 and solve for y. So for the x-intercept, we're going to substitute 2x plus 3, and instead of y, we're going to substitute 0 in, equals 12. 3 times 0 makes 0, so that cancels. So we're left with 2x equals 12, divide by 2, x equals 6. So now I have one of my two intercepts at the point 6, 0. And then I'm going to solve for the y-intercept by substituting 0 in place of x. So this time it'll be 2 times 0 plus 3y equals 12. Well, 2 times 0 makes 0, so we can divide both sides by 3 to get y equals 4. And then the second intercept that we have is 0, 4. All we need in order to make a line is 2 points, and when you use the intercept method, that's exactly what you have. And now that I have the 2 points, I can calculate the slope, I can count the slope. I'm going to just count it because I can see that we go down 1, 2, 3, 4, and then to the right 1, 2, 3, 4, 5, 6 spaces. So from the y-intercept, I'm going to go up 4 and then to the left 6 spaces. We'll try one more example like that. We're going to graph negative x minus 4y equals 8. So again, this is written in standard form because x and y are on the same side. So for the x-intercept, we're going to substitute 0 in place of y, solve for x. Four times 0 makes 0 again. So we're left with negative x equals negative 8. So we're almost done, but not quite, because we need that negative sign to go away. And you can think about it as like negative 1. So if you want to divide both sides by negative 1, the negatives will cancel, and we have x equals 8. So the x-intercept will be at 8, 0. And for the y-intercept, we substitute 0 in place of x. We can cross off the 0. There's still a negative sign, so be careful. When you divide both sides by negative 4, we should get that y equals 2. So then the y-intercept will be located at 0, 2. So between these 2 points, we go down 2 spaces and to the right 8. So we can also go up 2 spaces and then to the left 8. And then connect your points. The last topic we're going to cover is how to graph horizontal lines and vertical lines. So if you have y equals some number, it's going to be horizontal. And then if you have x equals some number, you will have a vertical line. So for the graph of y equals negative 1, we're going to look on the y-axis, find the number negative 1, and then just draw a horizontal line. And then for the graph of x equals 2, look on the x-axis, plot a point on the number 2, and draw a vertical line passing through that point. For these last 2 questions, you can use whichever method is easier. For the first example, we have 3y equals 2x minus 12. Y is almost on a side by itself. All we have to do is divide by 3. Remember to distribute or divide both terms by 3. And we have the equation y equals 2/3 x minus 4. So for that first equation, because y didn't have anything else on the same side other than the coefficient, it's probably easier to just use slope-intercept form. And then for the second equation, x and y are on the same side. So it's easier to just get rid of this 4 that's out in front of our equation, divide both sides by 4, and then use the intercept method. Solve for the x-intercept, where y equals 0, and then solve for the y-intercept, where x equals 0. Pause and review the algebra steps that went with that. By all means, go ahead. After we worked it out, we saw that the x-intercept was at negative 10, 0, y-intercept is at 0, 5. So we went to the right 10, up 5. Do that one more time, the right 10, up 5. And connect your points. And that is all. So if you have any questions, make sure you let us know.